Assalamualaikum warahmatullahi taala wabarakatuh.
Salam doktor.
Waalaikumsalam doktor.
So I'm going to share the screen. Okay, can you see the white screen?
Yes.
Okay. Okay, so for today's class, we will continue to show the isomorphism between two transformations. So this is our second example. So just to recall the definition of isomorphism. Okay. So we have the MPT or the measure preserving transformation. On X sigma algebra mu T. So the measure preserving transformation T on the first probability space. So F1, F1 mu1 and S. The second transformation S on the second space, probability space, F2 mu2 are called isomorphic. So if there exists one-to-one correspondence from phi from X that brings from the domain X to Y. Okay, such that it satisfies these three properties. So the first one is for any A in the first sigma algebra, we will have the measure, the image phi A is in the F2 and B from F2, so the image or the pre-image of B will be in F1. Next, for any A in F1, so we have the measure, so mu1A is equals to the mu2 of the image of A. Since this is a one-to-one correspondence, okay, and then automatically we will have for any B in F2, we have the measure mu2B is equals to the mu1 of the pre-image of B. And the third one is the commutativity. So we have from X for any X in this X. So we will have psi of the transformation X is equals to S of phi X. Okay, so the second example that we want to show is for the Becker's transformation and also the Bernoulli. Okay, so now we go for Becker's. Example number 2. Oops. So I have to start from here. Okay, new page. So for Becker's transformation. So we have the map is from X, which is equals to the segment 0, 1 multiplied with segment 0, 1 is the product of two segments. And we have B. So we call the Becker's transformation as B. So in previous example, which is example number 1, we consider T and S. So in this case, we consider B for Becker's. And for another one is Bernoulli S. We call it shift. Bernoulli shift is for we use S transformation. Okay. So BXY or the Becker's transformation is defined by this formula. So we have 2x 1 over 2y. For the case of x is between 0 and half. And then for the second segment, we have 2x minus 1 and half of y plus 1. Okay, for the case of 1 over 2, when x is between half and 1. Okay. So now, the second transformation, we consider Bernoulli shift, but in a double-sided sequence. Okay, so we have again, we have the set of 0 and 1. And we define the Bernoulli measure. So Bernoulli, so V0 is equals to 1 over 2 and V1 is equals to 1 over 2. And we define Y, which is the double-sided transformation, another space lah. Y, which is the partition function of from minus infinity to infinity of EI. So here omega taken from this Y, and we have the sequence is given by this formula. So we have this is the double-sided. So we have from ... until omega 2, omega 1, omega 0, omega 1, omega 2, and so on. So this is the sequence of double-sided sequence. So the shift or the Bernoulli shift is given by this as omega n is equals to omega n plus 1. If we apply the transformation here, so it is like shifting. Okay, next. Question so far? No. Okay, it's just the introduction of another two transformations. Okay, now. So we let these two coordinates x and y is taken from the measure x, a measure like space x. So if x and y, that means we will have two coordinates for x and also for y. So for x, we can write as 0 point, x1, x2, x3, x4, and so on. So in previous example, we have only x, kan? But for the case, because there is only one-sided sequence. But for this case, we consider two-sided sequence. So we want to now in the step of we want to generate want to formulate a one-to-one correspondence of psi ataupun of phi tadi from x to y. So this is how we formulate the one-to-one correspondence. So for x, we have 0 point x1, x2, x3, x4. So for y, we have 0 point y1, y2, y3, and y4, and so on. Okay. So this is the two coordinates. We define psi. So this is this symbol, we call it as psi from x to y. Okay. So that means the xy, the coordinate xy can be rewritten as here 0 point x1, x2, x3, and so on. Tadi comma. So the second coordinate is 0 point y1, y2, y3, and so on. Okay. Sekejap Okay, so we will have the image. Now we want to find the image of this xy. Becomes what? So let's see. So the image is quite tricky. So first you have to, let's list down all the coordinates ni. So we will have here in the middle, because this is two-sided. So in the middle, this one is 0, 1, 2. Maksudnya the first digit is 0 here, 0 here. Ni the second digit, ni the third digit, and so on. Okay, so we have 3 and again so on. So in this part on the left would be -1, -2, -3, -4, and so on. Okay. Now how to list the coordinates that we have here? Yang ni je lah. Besar sangat pula. Okay. So first kali, ni lah. First kali 0 ni dekat sini kan? Okay, 0 dekat sini. So what is the digit dekat sini? So for the 0 case here is for x. For the positive part here is for x here. Okay, so that means 0 point ni kita tak ambil 0 kat depan tu, tapi kita ambil sini. So the digit here is x1 on the 0th place, or the first digit here. And the second one here x2, here x3. Okay, and so on lah. Now for the y part here on the negative. Bukanlah nak kata nombor dia negatif, tapi dia punya side tu dekat belah kiri. So dia terbalik. So ini again the 0 here kita tak payah tulis, kita just tulis. So the -1, the first digit here is y1, second digit is y2, y3, and so on. Is that okay? Okay.
Okay.
Alright. So that means we have created, generated its one-to-one correspondence already for the case for this lah, for this map. So that means this is one-to-one correspondence. Okay. So now you can show, nak show yang dia isomorphic. You can show for the condition number 2 and condition number 1 on your own. You can try it by yourself. It's just like a home task. Macam you show in the first example lah. So, but the interesting part is you can, I want to show for the third condition, which is the commutativity.
Doktor,
Ya, ya.
selepas dah buat psi tu, dia jadi set kan yang
Macam mana?
Y4.
Aha.
Dia psi ni dia set jadi dia
Set.
Y4, Y3 ke bukan?
Bukan. Dia digit dekat sini. Sekejap. Psi ni kan kita nak create one-to-one correspondence, betul? Sebab according to our, according to our ni definition, it is exists one-to-one correspondence of phi x to y. So sekarang saya tak guna phi, saya guna psi because saya nak different example. So yang example dia saya guna untuk Beckers dengan yang ni lah, untuk double sided. So double sided punya sequence kita tulis macam ni. Ada -1, -2, 0, 1, 2. So -1, -2 ni ada position of the coordinate function tu. So coordinate sini ni lah, -1, -2, -3. So ini adalah dia punya coordinate for this xy. So kalau xy, x belah kiri ni kan 0, x1, x2, x3, tapi kita punya digit tu kita write as this. But positive, macam ni, positive sequence punya order ni on the right ni adalah untuk x, on the left ni adalah untuk y. Dia bukan set, dia kita nak Dia mapping one-to-one correspondence from psi from X to Y. X tadi daripada mana? Inilah apa dia punya domain X, apa element of X dalam ni adalah XY sebab kita consider Becker. Becker ada dua koordinat, betul?
Betul.
Okay, to Y maksudnya to the image dia mestilah kena dalam bentuk double sided sequence sebab kita nak between ni dengan ini. Ni dia kan dalam bentuk double sided ni. So kita kena generate one-to-one correspondence between these two transformation guna benda ni. One-to-one correspondence dia. So ini cara dia. First dia define the one-to-one correspondence by this way lah. Guna psi xy is given by this formula.
So dia dari XY tu kan koordinat kan?
Yes.
Lepas tu bila dia dah mapping tu dia jadi digit. Sequence of digit.
Sequence of double infinite sequence.
Sequence lah ni.
Sequence.
So
Sebab-
sepatutnya dia koma ke tak? Tak eh?
Tak ada. Dia macam apa? Dia tak ada koma. Dia macam ni. Awak return dia like this. Okay, you write it like this way. Ni. Dia punya digit tu from this, okay? From this coordinate macam ni. 0 point berapa-berapa, 0 point y berapa-berapa. Actually dia punya position sebenarnya kata dia punya one-to-one correspondent ni mapping xy kita define it to be like this. Ni macam ni. Dia punya position dia x1, x2, x3, x4 and then belah kiri y1, y2, y3, y4. Sebenarnya kita nak bagi tahu yang position each point dalam ni adalah dia correspond dengan satu digit dekat setiap satu digit dekat order dia. Ni order dia kan? 0, 1, 2, 3, something. Maksudnya macam mana? Setiap digit ni correspond to the image tu kita dapat dekat sini. Macam tu. Kalau X2 dia dekat sini. So dia ni maksudnya kita nak formulate one-to-one correspondence dia lah.
Faham?
Okay. Alright. Thank you for the questions. Okay, now we move on. We move on. Okay, ingat untuk for the case, untuk yang ni, psi xy, you can write it this way. Okay, next. So for condition number 3, I'm going to show you for the condition number 3. So 3 tadi. Okay. So again, I have x. Okay, and then I have y to y. So now our transformation is B and this is shift S. And then this one is one-to-one correspondence psi and this one is psi. Okay. So for the third conditions, we want to show that apa tu? Okay, psi B xy is equals to S of psi of xy. Okay. Dia ikut pada transformation. So we have our commutative punya map is this. Okay, now again xy is taken from this lah. 0, 1 and 0, 1. Okay, now for Becker's we need to consider two cases. Sebab for Becker's we have two cases kan? Bxy. So this one we have 2x. So for the first case is between 0 and half. And for the second case is between half and 1. So you need to consider both cases. To show the isomorphism between these two transformations. Okay, now for the first case. Okay, case case 1 is between x 0, x and half. Saya nak cas laptop kejap. Okay, so for the first case between this. So first what do you do? First case yang ni lah, kita nak show yang this part. For the left hand side part for the first case, kita akan guna ni lah. Psi bxy. So the first what we want to find. So we have to find bxy first. Backers. Okay. So you have the xy already. You know bxy kan? So jap. So xy is xy tadi, you can write it as this, right? x1, x2, x3 and so on. And y you have 0.y1, y2, y3 and so on. Okay, so you want to find the transformation of xy. Here what do you have? So for bxy in the first case you have 2x dengan half of y. Okay, you apply this for x here. Ni ha. Apply this half, 2 dengan half dekat, okay, kita apply 2 dekat x, kita apply half dekat y. Macam mana nak apply tu jadi apa? So kalau 2x, you can write it as, the case dia macam ni. Kalau contoh, kalau 0.14 darab 10 akan jadi apa?
1.4.
1.4. Kalau kita ambil mode 1,
0.4.
0.4. Okay, so 0.4 ni adalah actually the second digit kan? Ni. So you have 0.x2. Sebab x1 tu macam kita dah cancel. Lepas kita darab dengan 10. Betul eh? Okay, so now kalau kita apply untuk 2 pula. Macam mana? Sama je. Dia punya method tu lebih kurang sama. So you will have
0.x2.
yeah, 0.x2, x3 and so on. Bukan koma. Okay, now for the half darab dengan y macam mana? Okay, for kalau kita bahagi dengan 2, macam kita mula-mula kita tunjuk bahagi dengan contoh 0.14 divide by 10. Kan dapat?
0.014.
0.014. So that means kita add another extra 0 dekat first digit. So this becomes 0.0y1, y2. Faham tak? Boleh nampak tak? Okay. Okay, so now kalau kalau half kita apply darab dengan y ni, kita akan dapat 0.0y1, y2, y3 and so on. Macam kita tambah extra 0 in the first digit lah. Okay. Okay, so now for the image of bxy kita dah dapat. Now what do you want to do? So now you want to find the psi. Okay, the psi of, inilah, saya tulis kat sini lah. Mana lain? Okay, psi of b of xy. For this case, again, I write it as this. Okay, kita ada dua double sequence. So the tengah ni, and then we have 0, 1, 2, 3, and so on. And the order of -1, -2, -3, -4, and so on. Okay, apa values dia kat sini? So sekarang 0. Sebab so sekarang ni kalau kita tengok dekat jawapan dia kat sini, dekat BXY tadi, this one, starting the first digit dia adalah x2. So the zero position here is x2, x3, x4, and so on. Is that okay? Yeah, alright.
Yeah.
Okay, now for the case of for the y position, kita akan dapat, so the first digit here is 0. So that means here is 0. So we have y1, y2, y3, and so on. Okay, so this you can write the psi bxy is like this. So this is your macam your image lah. Sebab kita punya jawapan sebelum ni kita define psi xy as like this. Okay, so you can leave your answer like that. Yeah. So psi bxy adalah dalam bentuk ini. Okay, now kita dah settle on the left hand side. Left hand side for the case of less than half. Now kita consider the right hand side, but for the case of less than half. Maksudnya for the same case lah. So we will have right hand side tadi berapa? S of psi xy. So this is the right hand side yang kita nak tunjuk tadi. So first kita kena cari psi xy. So psi xy tadi adalah again you will have 0, x1, x2, x3, and so on. And then the y coordinate you have 0, y1, y2, y3, and so on. So this position here, so you know that this is the this is equals to, I can write here. So I can have this y3, y2, y1, and then you have x1, x2, x3. Okay, this one is the position lah. So you have this is 0, 1, 2, and this one -1, -2, -3, and so on. Okay. Okay, now so you already know that psi bxy is this. Psi bxy is this one. y2, y1. Oops. Okay, y2, y1, 0, x2, x3. Ini dapat daripada previous. Apa benda ni? Okay. Alright. So yang ni dapat daripada ni tadilah. Psi bxy. So you have y3 betul lah. y2, y1, 0, x2, x3. So this one is for the case of x less than half. So if you look at the here, apa maksud dia ni? This is 0 kan? So this 0 ni actually apa? Kalau tengok dekat psi xy ni, 0 ni apa?
Y0.
X1 kan?
X1.
Kalau tengok kat psi xy. So kalau kita tengok psi bxy, kita dapat 0 kat sini. Ada maksudnya 0 kat sini. This 0. Sekejap saya tunjuk dengan ni lah. Okay, this 0. So what is the value, what is the name for this 0? This is
X1.
actually x1. Yes, correct. This is actually x1 that coming from here. So, okay, so what can you write? So for the S, so the S here, you can write it as S of this. Okay, it's like we shift this to the left. Okay, we shift to the left. Apa maksud shift? So if you have the, again, the doubly sequence, so the order for the sequence is, this one is 0, 1, 2, minus 1, minus 2, minus 3. So you will have 0 tadi. It's like you shifting this part, shifting. Sebab psi xy kan kita tengok psi xy, so kita tengok kat sini lah. So we shift to the left. So jadi position 0 x1 tadi tu, 0 is x1 punya position. So we shift to the left. That means the 0 position now become the position for
X2.
-1.
X2.
So 0 position. 0 position is x2. Kita bawa dia ke kiri. Tolak. So -1 tadi tu, position -1 jadi x1. So position -2 jadi y1 lah. And position -3 jadi y2 and so on. So the right position ini, the first position becomes x3, x4 and so on. Is that okay? So this case sama tak dengan the left hand side tadi? So the
Sama.
0 sama kan? Sebab kalau ikutkan ni 0 ni adalah x1. Boleh? Boleh kan? Okay, so ni sama lah. So that means our ni, this one, psi bxy and s psi xy is the same. So we can say that there are commutativity between the transformations of Beckers and also the double-sided of Bernoulli shift. For the case of less than half, ni baru first case. Case of 0 and half. Now for the case of the second case. Is that okay? Until now, any questions?
Doktor,
Yeah?
yang dekat XY tu kan dah selepas kita Baker's transform dia tu,
Yang ni?
kan X1 dah hilang kan?
Sorry?
Selepas kita dah cat transform dia, Baker's.
Yang ni? Beckers.
Atas lagi.
Atas lagi. Ni?
Okay. Ni kan X1-nya dah hilang kan?
Ya.
Lepas tu bila psi kan dia jadi kosong. So
Ya,
kosong
betul.
kat sini dengan X1 dekat XY ni sama ke?
Yes, sebab X1 apa ingat tak? Kalau between 0 dengan half, apa itu first digit dia? Ingat tak saya tunjuk example dulu. Hari Selasa baru ni. Kalau 0 dengan half, apa the first digit dia? X1 kan? X1 is 0, betul tak? Ingat tak? Ni the first digit, ini second digit. Sorry, tak ada second digit. Sebab X1 can be 0 or can be 1, betul? So kalau between this segment, the first digit is 0. Boleh tak?
Faham.
Dia related lah dengan kita punya example yang previously. So actually memang ini adalah X1. Betul, I understand your question. So bila kita darab dengan 2, X1 kita macam hilang kan? Tapi actually dia appear balik. Disebabkan oleh dua benda ni. Sebab kita potong, lepas tu kita batang balik, lepas tu kita shift. Lepas tu kita shift, kita pergi balik. Dia macam tu lah, dia pusing-pusing. Sebenarnya dia tak hilang pun, dia ada kat situ. Cuma disembunyikan buat sementara waktu. Okay. So kalau yang ikutkan, kalau dekat case ni, the first digit is 0. So that's why kita akan dapat sinilah 0. Okay. Okay, slowly. Okay, now second case. Case half between x between 1. So kalau between this, first digit is berapa?
1.
1, correct. Sebab tu dia datang macam tu lah. So between these inequalities, our first digit is 1. Okay, now kita do the same, which is we want to find the commutativity by showing that our left hand side equals to the right hand side. Okay, so you have psi of b x y is equals to s of psi x y. Now we want to show this. So the first one is b x y. So again, for the second inequality, you have this one. The basis is 2x minus 1 and half of y plus 1. Okay. Okay, macam mana kita nak cari? First, we know x is, you can write it as 0. Okay, so since the first digit is 1, so x2 can be written as 0.1, x2, x3 and so on. Boleh faham kat sini?
Faham.
Sebab kita tulis x1 pun boleh, tapi sebab kita dah tahu x1 tu 1, so kita boleh tulis 1, straight away kita boleh tulis the first digit tu 1 lah. Okay, so now kita apply 2x. Sebab kita nak guna yang ni. So 2x macam mana dapat berapa? Kita pindah perpuluhan, betul? So kita akan dapat 1.x2, x3 and so on. Okay, now we subtract with 1. 2x minus 1. So you will have 0.x2, x3 and so on. Is that okay? Alright, so now we go to, now we go to the y pula. So y, this is actually half of y plus half kan? Okay, now kita buat satu-satu. Y can be written as 0.y1, y2, y3 and so on. Lepas tu 1 over 2y. Kita divide dengan 2, kita akan dapat 0.0, y1, y2, y3. Okay. Now we plus with half. Apa maksud plus ni kat sini? Plus ni maksudnya kita tambah lagi the first digit. So kita akan dapat 0. Sebab the first digit is 1. So we have bukan x. Kita akan dapat 0.1 y1 y1 y2 y3. Is that okay? Kita tambah half, maksudnya kita tambah lagi half. Sebab dia side belah sini. Side belah sini. So kita tambah half, that means kita tambah 1 in the first digit. Okay. Boleh Okay. Now we go to find the BXY. So kalau you write this as, you can write BXY is equals to these numbers lah. Because you already found this and this. So 0.x2, x3 and so on. And then this one is 0.1, y1, y2, y3 and so on. Okay. 1 Okay. Okay, so we apply the psi to the BXY. So psi of B of XY is equals to, again, we write it in terms of this lah. So I write as 0, 1, 2, 3 and this one position number -1, -2, -3 and so on. Okay, so I have so the position according to the BXY that we have just now, this is x2, this is x3, this is x4 and so on lah. And for the left hand side, you will have this is 1, this is y1, this is y2 and so on. Okay, but in fact this one is actually this one here is actually
X1.
x1. Correct. Okay, now we go to the right hand side. So for the right hand side, okay, laju sangat. Nak salin?
Nah.
Okay, jap. Okay, I give you 2-3 minutes to salin. Okay. All right. So next one, try to show the last one on your own. Okay. Nanti kita discuss. Okay. Okay. Try to show for this. S of psi x y. Okay, we will discuss the solutions 5 minutes. Okay, dah siap? Senang kan? So for psi xy, kita dah tahu psi xy tadi. So kalau kita shift to the left, okay, so you will have, okay, again psi xy is given by, so here 0, x1, x2, x3, and then here 0.y1, y2, y3. Okay. So in this case, I have x1, x2, x3, and then I have y1, y2, y3. So this is position of 0, 1, 2. This is minus 1, minus 2, minus 3. Kita shift to the left. S of psi of xy. Shifting to the left, that means you will have position ni bertukar. So again I have this 0, 1, 2, minus 1, minus 2, minus 3. So x1 here ada dekat sini, x2 dekat sini, x3 and so on. So in this part I have y1, y2 and so on. Betul? Okay. So the conclusion is the Baker's transformation and Bernoulli shift for the double-sided sequence is isomorphic. Since Bernoulli shift is ergodic and mixing, okay, I think you know from previous classes, Bernoulli shift is ergodic and mixing. So this also applies for Baker's transformation. So that means Baker's transformation also ergodic and mixing. Okay, so this is what the applications of isomorphism. So why we need to check the isomorphism between these two transformations is because we want to see whether the properties of the first transformation is the same or not. So kalau properties the same, selalunya we can just analyze the one of the transformation je lah. Selalunya kalau kita dah analyze, let's say kita dapat Baker's to isomorphism dengan Bernoulli, so kita boleh pilih salah satu transformation mana yang lebih senang untuk kita analisis, to do analysis. Sebab kalau apa-apa yang jadi dalam Baker's itu boleh dapat juga boleh jadi dalam Bernoulli. That is the application, one of the applications of finding isomorphism. Okay, any questions so far? No. Okay, good. Okay, now for the case, yeah. Ada question?
Nak tanya.
Tak ada.
Untuk yang ni, kita
Ya.
tahu X1 kita 1, tak boleh ke kita ganti terus dekat XY atas tu? Jadi macam 0.1 X2 X3 tak boleh.
0.1 S2. Oh, boleh. Tak ada masalah.
Okay.
But the thing is, kita just nak show dia punya left hand side sama dengan right hand side lah. Kalau you define it 1 kat sini, so in the previous example for the case of ni, awak kena letak ini 0 lah. Okay. Lepas tu tengok je left hand side sama tak dengan right hand side, because you know already. Okay. Good questions. Any more? No. Okay. If not, then we can just tak ada apa sangat pun. So we have finished about this topic, which is isomorphism. So there's some of the in the next class we will discuss about entropy. Okay, entropy. Ini next class lah. But I need you to boleh je nak introduce sekarang. So entropy we write it as H of T. So that means the entropy of the transformation T. So H ni kita panggil dia entropy. Ni memang dia dah guna zaman beratus-ratus tahun yang dulu. Entropy dia guna notation dia H. Okay. So kalau if T and S ataupun if these two transformation T and S are isomorphic, then T and S have the same entropy. Apa maksud dia? Maksudnya HT is equals to HS. So kalau T dengan S isomorphic, that means they have the same entropy. Ni kalau ikut entropy. So maksudnya kalau kat sini, kalau T dengan S macam tadi, T dengan S ergodic dengan mixing, that means S also ergodic dengan mixing. Kalau T and S isomorphic, kalau T tu entropy dia HT, so kalau dia orang isomorphic, that means they have the same entropy, sama. So what happens? The question is, what happened to its inverse. To its inverse tu maksudnya kalau dia orang sama entropi, adakah dia orang isomorphic? Soalan dia. Kita tahu kalau dia isomorphic, entropi sama. Tapi kalau dia entropi sama, adakah dia isomorphic? Generally, this is not true. Generally not true because we can find there are some of the measure preserving transformations for finite case. For any two transformations, they have the same entropy, but they are not isomorphic. Okay, there are particular cases lah for this case. So I think we finish early. So for the recap of our lesson for today's class, so we have introduced the notion of isomorphism. So for two transformations, and then that means that this by isomorphism we can determine that these transformations have the same property. That means that they are the copy of one another. So in the next class, we will define entropy and to discuss on how to compute the entropy for measure preserving transformations. Okay, questions?
No.
No, okay. So next week, we will have class again the same time and the same day. So see you next week, insyaAllah. Thank you for your patience and also for your kindness to hear my lecture. And see you next week, insyaAllah. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam. Thank you, Doktor.
Okay.